Okay, so this is a video on writing exponential equations from word problems. Now, I know word problems are not everybody's favorite thing, but these are not going to be that difficult. Today we're going to look at two things. We're going to either classify them as growth or decay, and then we're going to actually write some very simple word problems. And based on the work we've already been doing, writing them shouldn't be that bad. Now we are going to move into some more complex problems next week, and we're going to do follow-up questions with these easy problems tomorrow. Well, so they are going to get a little harder, but today is pretty easy. It's pretty straightforward. We're just going to identify growth and decay and then write some basic problems. Okay, so the key to today is that you read the problem. If you don't read it, you're going to get lost. You can't just look at it and assume the numbers. You got to read and comprehend what's going on in the problem. And when you comprehend and read it, the first time you read through, you're looking for one of two things. You're going to decide if it's growth or decay. Now, if the problem implies that things are growing, getting larger, getting bigger, then it's exponential growth. Okay, and that's important because all the work we've been doing so far, if it's exponential growth, our b value is bigger than 1. So when we write our problem, our b value needs to be some number bigger than 1. Today they're going to be nice numbers like 2, 3, 4, 5, nice whole numbers, but we are going to move into complex problems next week that have percents in them. So you might see percents today, but don't get hung up on the fact that they're there. That's just to introduce them to you, so next week when we see them and we do work with them, they're not going to be a completely foreign idea to you. Today though, when we write them, nice numbers. So it could be growth, or if the problem implies that things are decreasing or getting smaller, then it's exponential decay. And that's important because if it's exponential decay, our b value is between 0 and 1. And again, today those values are going to be nice, something like 1/2, 1/3, 1/4, a nice fraction that you should be able to identify. As we move into next week, they'll get a little more complex when we do percents, but nothing to get worried about. Okay, so that's the first time we read through a problem. We want to decide if it's growth or decay. Now, depending on what I'm asking, you may only have to read it once, but when we write equations, you're going to have to read it a second time. And when we read our problem the second time, we're looking for the start value and what the problem's doing. Those two things are going to help us write our equation. The start value is the same thing as our 0 point on our graph, and that's important because that's going to tell us the a value in our equation. That's where we start. Okay, what it's doing, that is our b value, and that comes from these two things up here. If it's growth, the b value needs to be bigger than 1. If it's decay, the b value needs to be between 0 and 1, so they should match whatever you decide it is. That's what we locate the second time we read through a problem. Okay, we've got some examples here, and on these examples, it's asking us to just determine if it's growth or decay. That means these problems are one read through. We have to read, and we're going to find the keyword on what it's doing and decide if it's growth or decay. Now, the keywords may not be super straightforward. You might have to think a little bit, but we should be able to figure them out in the first read. Okay, so we've got 4 examples here. 1, 2, 3, 4. The first one says Amanda puts $1,000 in a money market account which grows at a rate of 3% each year. Well, the key word here is that it's growing. Since it's growing, our value, our money, or Amanda's money, is getting bigger, which means that this is going to be exponential growth. Now, the percent here, again, foreshadowing, looking forward to next week when we do percent problems. Yours today, when we write them, we're not going to have that in there. Okay, but it's exponential growth because her money is getting larger. Example 2, James put 3 bacteria in a petri dish and they double every 4 hours. Well, the key word here is double, and doubling means that it is growing. If I put 3 in there, okay, that's where we start. After 4 hours, I'm going to have twice as many because it's going to double. I'm going to have 6. And then 4 hours later, I'm going to have twice that. I'm going to have 12. So doubling is really times 2, okay, which means it's getting bigger. the number of bacteria. The longer I leave the bacteria in the petri dish, the more bacteria I will have. So that tells us that this is exponential growth. Example 3. A pond contains 500 fish. A pond that contains 500 fish was contaminated by a toxin that kills 45% of the fish each week. Alright, key word here, kills. Okay, if something is getting killed, it's dying off, it's getting smaller. So that population of 500 is getting smaller each week. Okay, that tells us, since it's getting smaller, that this is exponential decay, because the population from what it started with is getting fewer, is going down every week. Okay, and again, this one with the percent, something that we'll see next week. And the last one, number 4. It takes 8 hours for the Tylenol we take to decrease to half of the original amount we take. Well, the key word here, it's pretty obvious, is decrease. Okay, that automatically tells us that it's exponential decay. All right, a couple other words that you might see. You might see something like depreciate or appreciate. Okay, I'm sure you might have heard depreciate before. Appreciate is not something in this sense that many people have heard. But depreciate means something is getting smaller. Appreciate in value means that it's getting larger. So if you see those, that's going to tell you that it's growth or decay. The rest of them should be pretty obvious. You might have to think, like I said, a little bit, but they're going to be obvious if you're classifying whether it's going to be growth or decay. Just make sure that you find the key word on your first read-through. Now the next part of this is that we're going to write equations to model situations. This is where we have to do a second read-through. So the first read-through is going to be deciding whether it's growth or decay. Second read-through, we're going to find the A and the B value. Okay, so second read, this is where we locate A and B, and then we write our equation from that. So example 1, we're going to read it through once, and we're going to decide if it's growth or decay. It says, an initial rabbit population of 2 rabbits on a nature preserve, if left untouched, will double every 6 months. We saw this earlier, double. Okay, that's our key word. Double means that it's going to grow. So this is exponential growth, which tells us our B value needs to be bigger than 1. Okay, that's our first read-through. Second read-through, now we're going to decide, we're going to find our start number and what it's actually doing. So second read-through here, an initial rabbit population of 2 rabbits. Okay, that's important. That's where we're starting, so that's our A. My A value is 2. On a nature preserve, if left untouched, will double every 6 months. Doubling is what it's doing. Now the 6 months is a time period, and that's going to become important tomorrow when we do follow-up questions, but when we write them, not as important today. Okay? Double, though, is our B value, which means our B value is 2. So if we were going to write this, here's our form, A times B to the X, would be Y equals 2 rabbits to start with, and they are doubling every 6 months. That would be the equation that I want. And it's going to be that easy. You got to read through it, decide if it's growth or decay, and then find the A and the B value and plug them into an equation. Okay, example 2. I bought a rare coin in 1995 for $100. The value of the coin has tripled every year since then. Okay, keyword, tripled. Tripled, just like double, implies that it's getting bigger. So this is exponential growth. Okay, now we have some other numbers in here, so let's make sure when we read through it the second time we pick the right ones for our problem. I bought a rare coin in 1995 for $100. Well, the 100 here is my A value. That's what I paid for this before it started tripling in value. That's my start value. The value of the coin has tripled every year since then. Tripled. Okay, this is my B, which means my B is 3, because tripled means I'm multiplying by 3 every time. Okay, 1995 ties in with the time, and like I said, that will be important tomorrow when we do the follow-up questions. So today, let's write this in our form. Y equals 100 was our A, because we paid $100 for the coin, and then it's tripling every year after that. So our b value is 3. Okay, there's 2 growth examples for you. Hopefully that makes sense with the 2 reads what we're looking for. Okay, I've got 2 more examples here. You guessed it, they're probably going to be decay because we did 2 growth. Okay, so example 3. When 4 foxes are introduced to the nature preserve, the rabbit population of 2,000 decreases by half every 3 months. Okay, so decreases, keyword. That tells us that this is going to be exponential decay, which means that b value needs to be between 0 and 1. Okay, so let's read through it a second time and find the a and the b so that we can write our equation. When 4 foxes are introduced to the nature preserve, the rabbit population of 2,000 decreases by half every 3 months. Well, decreases is talking about our rabbit population, and the starting rabbit population is 2,000. So that's our A. 4 foxes, it's a nice number, okay, but we're not talking about the fox population here. We're talking about the rabbit population decreasing. So that's why we're picking 2,000. And how much does it decrease by? Well, it decreases by half. So then my B is 1/2, okay, which makes sense because B has to be between 0 and 1. So let's fill in our problem. Y equals A times B to the X. So it would be Y equals, our starting rabbit population when the foxes are introduced is 2,000, and it's decreasing by half every 3 months. Okay, so there is our equation. Y equals 2,000 times 1/2 to the X. Last example here, example 4. I bought an antique lamp for $1,500 thinking it was something special, but the value of the lamp depreciates by 50% every 2 years. Okay, so the key word here, depreciates. I gave that to you a little earlier with depreciate and appreciate. That's a case where we would use depreciate, and that's the sense you'd see it in. So depreciate tells us that it's exponential decay. The value of my lamp is going down every 2 years. That's our first read. Second read, I bought an antique lamp for $1,500. Well, there is my A value. That's how much I paid for that lamp. And it's nothing special because it's losing value. Okay, but the value of the lamp depreciates by 50%. Okay, so I did give you a percentage here today, but I gave you a nice percentage. 50% means that something is getting cut in half. Okay, it's a nice percentage. So that tells us our B value is 1/2. So when we write our problem, Y equals 1,500 times 1/2 to the X power. And there is our equation. Okay, so those are the problems you're going to see today on your Schoology assignment. You're going to have 2 types. The first type where we classify, and then the second type here where we're writing. Okay, a couple things to review real quick. You need to make sure that you read the whole problem and that you're doing the right number of reads. Remember, on the first read, we are just deciding whether it is growth or decay. And on our second read, we are finding the A and the B value to write an equation. Okay. The second thing I said here, you need to identify if it's growth or decay. That's what I was just talking about. This is our first read, and then determine the start value, which is the A, and what's happening to that value, B, on the second read. Okay, make sure you ask questions in the discussion board if you have any today. Otherwise, good luck on your Schoology assignment.